You're welcome to my channel. Today I want to look at three mathematical equations, and I would like you to pick the one that you prefer from the three equations. Now the first one, we have x to power of y equal 4 to power of 6. That's the first equation. And equation 2 says 1 plus log x in base 4. We have to look for the value of x and y. How do we go about that? Okay, let's call this equation 1 and I'll call this equation 2. So I'll start from equation 2. 1, since this is log in base 4, remember log a in base a is 1. So if this log is in base 4, I can write it as log 4 in base 4. This is also 1. So I'll use this to rewrite this one. So equation 2 becomes y equal log 4 in base 4 plus log x in base 4. So let's quickly recall the first law of logarithm that states that if I have log of a, let me say log of x in base b plus log of y in base b equal log xy in base b. So we are applying this law to this particular point here, since we have what? Addition, and they are of the same base. Cool. So this becomes y equal log in base 4 of this will become 4, right? Times x. That's 4x. Are we together? So from the definition of logarithm of a number to a certain base n, that is log n in base b, log of a number n in base b equal x. What this simply means is that the log of a number is equal to the power to which the base can be raised. So from here I can write this as 4x equal 4 to power of y. So if 4x equal 4 to power of y, let me call this equation 3. Okay, so from equation 3 now, I'm going to proceed and see what I can end up having. Okay, now from here, I can divide both sides by 4. So I'll say divide equation 3 by 4. Divide equation 3 by 4. Therefore, we have that x equal 4 to power of y minus 1. So anywhere I find x now, I can put 4 to power of y minus 1 there. So put this in equation 1. So equation 1 will become 4 to power of y minus 1, or raised to power of y equal 4 to power of 6. It's as simple as that. So this becomes 4 raised to power y square minus y equal 4 to power of 6. So that this and this can cancel. Cool. We have what? Y square minus y equals 6. So y square minus y minus 6 equals 0. So by factorization, this becomes y minus 3 into y plus 2 equals 0. So if you factorize, this is what we have. We therefore have that y equal 3 or y equal negative 2. So if this is the value for y, we can get the value for x now. So when y equal 3, x becomes what? 4 to power of 3 minus 1, and that's 16. And when y equal negative 2, x becomes what? 4 to power of negative 3. And that will give us 1 all over 64. Thus, the general equation for this question, that is the general solution rather, for this question becomes 16, that is x equals 16, y equal 3, and x equal 1 to 64 when y is negative 2. So that's question 1. Do you love it? Okay, let's see question 2 now. Okay, question number 2 states that x to power of log y equal 2x minus 5, and equation 2 states y to power of log x equal x plus 12. This is equation 1 and this is equation 2. How do I go about this? Oh, okay, before we even try to solve this question, I want you to understand that this and this are equal. That is 2x minus 5 is actually equal to x plus 12. How is that possible? Because x to power of log y is the same as y to power of log x. So let's quickly look into that. How can I go about that? Let me quickly prove that to you, that this is actually equal to this. So let that be the plus here. So let's say a equal x log y and b equal y log x. Now let me take the natural log of both sides. Natural log means I'm taking the log of both sides to base e. So if I do that, I'll have that ln of a equal ln of x to power of log y. So what I want to show is that this is actually equal to this. So I'm dealing with this now. So this will become ln a equal log in base log y in base 10 multiplied by what? The natural log of x. Okay, if that should be the case now, I can come to the other side here. So I'm going to have here that the ln of b is actually equal ln of y log ln of y raised to power of log x. Okay, so ln of b equal log of x ln of y. Okay, are we together now? So if we look at this now, we are going to see that this and this are actually the same thing. So if you look at this now, log y, okay, this is natural log. Okay. Let me do something. Okay, I think I'm going to contradict myself if I go by this way. So let me take the log of both sides to base 10 to play safe. Okay. Because if I intend to go the way I want to go like that, I will have to prove something else. And that's why, although if you go like that, you're still going to have the right answer today. But to avoid long story, let's come back to this and take the log of both sides to base 10. Please save guys. Okay? Log of a in base 10 equal log x to power of log of y. And here will also be log of b to base 10 is actually equal log of y to log of x. Cool. So this will become log of a equal log of y multiplied by log of x. Abi? And this one will become log of b actually equal log of x and log of y. So if you look at this now, this is log a, this is log b. Okay, so a here is equivalent to 10 to power of log y log x. Are you seeing this now? So I can take this like this, and here b is also the same thing as 10 to power of log x log y. So if you look at this now, you see that a and b are actually equal. Therefore, this log and this log are equal. So that's that about that. So let me quickly clean this now and go on. So you are convinced now that this and this are equal. So I have 2x minus 5 equal x plus 12. So I collect the like terms. I have 3x equal 15, right? Sorry. If this one should come to the other side, it becomes 17. Cool. So x equal 17 divided by 3. So this is the actual value of x. Okay? If there's no mistake, then we can go on. So if this one should come here, cool. Okay, sorry, there's a mistake. There's a mistake. Okay? If this one should come over here, it becomes plus, while it becomes negative. So 2x minus x equal 12 plus 5. So this becomes x equal 17. So I have the value of x to be 17 in that way. Okay? If that should be the case, can I get the value of y now? Yes, I can get the value of y by putting the value of x into equation 1. So if I put that into equation, okay, no, let me put it in equation 2 so that it will be more easier. I will not have to take log of both sides again. So putting this in equation 2, I have that y to power of log 17 equal 17 plus 12. So y to power of log 17 actually equal 29, right? Okay, if that should be the case, okay, I think I'll still have to take log of both sides again. Okay, Don't worry. So let's just go by this now. If I take log of both sides to be 10, I therefore have log y to the power of log 17 equal log of 29. Am I making sense? So if that should be the case, this one will come down here. So I therefore have that log y is actually equal log 29 divided by log 17. So y is therefore equal 10 to the power of log 29 divided by log 17. Okay, by the time you look for the value of this, I think y should be close to 15 approximately, if not 15.2. Okay, so x equals 17 and y equals 15.2, if I'm not mistaken. So you can just check for the value of that. I'm not that sure, but I think it should be. So that's the second one. Do you enjoy this one? I know some of us are learning something new about this question now. So let's go to the last one. And I think that is more awesome compared to the first two, to me though. Okay, so for the third question now, we have that x plus 1 to the power of x is actually equal, this is multiplied by e to the power of x plus 1, and this is actually equal negative x divided by 6 or to the power of x. Wow. This question will have been a very big problem if what is here is actually addition. Yes, if what is here is actually addition, it will have been more interesting than this. And you can see the graph of this function on the screen. And if you look at the graph you are seeing on the screen right now, you will see that the actual value of x is around the negative 1 over 2. Abi? Now let's see, let's solve correctly now, see how we can go about that to show that it's actually equal to what we have in the graph. For those of us that might like to plot the graph, you can just set this one to g of x, then you set this one to f of x, or vice versa. Then you get your result. Absolutely. Cool. Now, what am I going to do here? What I need to do here is to make x the subject of the formula, isn't it? Now, that might not be that easier for me, but again, it will be easier because we have here product. What I will do is to take the x root of both sides. If I take the x root of both sides, I have this and I have this to equal negative x over 6, because x root of both sides has made this x cancelled. Cool. Therefore, this one will become x plus y, x plus 1, then this one will be e1 plus 1 over x equal negative x divided by 6. Now watch something here. Do you see what I'm seeing here? No, you are not seeing it. I can actually apply Lambert's W function to this question here. But before I can apply Lambert's W function, remember that x of e of x, that is the Lambert W function of x of e of x, is actually equal x. Now I already have e to the power of 1 plus 1 over x. How can I make this one the same thing as the power, so that I can actually apply this? Then we're good to go. Yes, I can do that by dividing by x. So if I divide both sides by x, I therefore have 1 plus 1 over x, then e to the power of 1 plus 1 over x equal negative, this is supposed to be e. This is supposed to be e. This is supposed to be e. Sorry, I think I write the wrong question initially. So, absolutely, this is what we're supposed to have. Okay, so now that I have what is here, it's the same thing as what is here, so I can just take the product log of both sides. So if I take the product log of both sides, I have this one to be 1 plus 1 over x to equal negative 1, because the product log of negative 1 over e is actually negative 1. So if I take 1 to the other side, I should have 1 over x equal negative 2. So by cross multiplying, x equal negative 1 over 2. Quite easily done. So let me know the one you like, number 1 or 2 or 3. If you are checking the thumbnail, do you like color green or color yellow or color blue? Let me know.
the video.